There are some other branch extender limitations. I think I've gone through some of these, but I want to make sure we go through them all. So the first one is that the APPN Session Services Extensions architecture support. The branch extender products were not required to implement the APPN Session Services extensions. So as such, you're not going to get any slew-initiated sessions or queuing going across this boundary. That doesn't mean you can't have dependent LUs down here. You absolutely can. What it means is that if you have dependent LUs down here, all the session service extensions flows will occur between you and the DLUS who owns the DLUR, and then the only thing that actually flows down to these devices down here is the bind, and maybe the init itself when we first kick off the session. But you can't have a VTM end node down here, for example, and a VTM network node up here, and expect this VTM end node to be able to do a closed as pass across these branch extenders. In that case, the application down here is using this guy as his network node server. He is not SSC capable, and that's basically breaking the SSC rule. The owning CP and their network node servers all have to be capable of SSC in order to be able to do the SSC sessions. So the best you would get with a VTM end node down here are LU62 sessions between these two guys, and even that's probably not a good idea because VTM sessions can suck up a lot of bandwidth, and you wouldn't take much probably to inundate some small network nodes on the session path with a lot of traffic. All right. Second thing is DLUR support. I told you that branch extender nodes, BEX nodes, can be DLURs, but you cannot put a DLUR below a branch extender. If you use the cascaded branch extender model, then you have to use the highest level branch extender as your dependent LU requester. And that means any nodes below him would have to be able to support the dependent LU pass-through function if you wanted nodes even further below here. So if your dependent LUs are down here on the end nodes, and this guy is your DLUR, the node in the middle basically has to support one of those types of dependent LU pass-through function, so it looks like the dependent LUs are directly attached to the DLUR on the top. Finally, connection network support. You can use virtual routing nodes within a branch and between branch extenders within the branch, but what you can't do is use the virtual routing node as a way of circumventing a branch extender as being an intermediate node. For the VTM that owns this connection, way up here, has a connection to a virtual node, and this end node has a connection to the virtual. We will not be able to calculate a route path to bypass the branch extenders that goes directly from that VTM down to this end node. Whenever you start sessions down to resources below a branch extender, the branch extenders are definitely going to be on the session path. There's no way to avoid them. Okay, finally, we get into extended border nodes. Extended border nodes are VTM's version of an SNI gateway, so that you can connect your APPN network to another customer or another enterprise's APPN network. We called it multi-subnetwork connectivity if you're looking at it in our books, but it really is the APPN version of SNI. The border node function is an optional tower, but it's an optional tower on top of the base APPN network node function plus SSE. So a base APPN product cannot be a border node unless it's willing to suck in all of the SSE functions as well as doing the border node functions. And there have been literally or virtually no other APPN products who have been willing to do that. So right now, VTM is pretty much the only APPN border node that's out there. Border nodes restrict topology flows across subnetwork boundaries, just like an end node would, just like a branch extender would, but this time it does it by virtue of the fact that the border node knows where the network boundaries are and doesn't allow native topology to flow to non-native nodes. Border nodes will also allow searches to flow seamlessly across the network boundaries so that we can locate resources, and then we calculate our routes piecemeal in each APPN network and concatenate them all together for the end-to-end session path, if you will. So EBNs can support two types of subnetwork boundary. We talk about the peripheral network boundary, and we talk about the extended network boundary. The peripheral boundary means that you've got a border node on only one side of the boundary. The node on the other side is got to be a network node, but it's a network node that does not support the border node function. If it's an end node on the other side, it's considered a native end node, and that's true even if the end node has a different net ID than the network node server he's starting CP/CP sessions with. The casual connection of end nodes with different net IDs has always been allowed by the APPN architecture. So an EBN, a peripheral boundary, is a border node in one APPN network that has a non-native connection to a base APPN node, a non-border node APPN network node in the next APPN network. In order for the network node to be able to start CP/CP sessions to another node in a different net ID, that other node has to look like an end node. If it looks like a network node, the architecture says if I'm not border node capable and I'm trying to start CP/CP sessions to a network node with a different net ID, I have to reject the connection, right? So instead, during pre-negotiation, one network node says, yeah, I'm a network node in net B, and the other guy says, yeah, I'm a border node in net A, but the other guy doesn't know anything about that. And you negotiate that and you say, oh, he's just a network node, he's not a border node. So when you go through negotiation proceeding, the border node, instead of saying he's a network node, says he's an end node. And that allows this network node to establish CP/CP sessions. So that's another case where a node looks like an end node, even though it's got the network node functionality. All right? That's what happens on a peripheral boundary. The border node ends up acting like an end node to the adjacent non-native network node. An extended network boundary, on the other hand, are two border nodes who both attach to a border node in the other network. Now, during the pre-negotiation, we realize we're both border nodes, and we don't have to fake out the other guy. We can actually just basically say, okay, you're a border node, I'm a border node, then let's come up with a network node to network node connection, but understand that we don't send topology across here. That's basically the idea. All right, so you've got peripheral network boundaries, you've got extended network boundaries. Peripheral boundaries have a lot of limitations inherent in them, and that's why we don't recommend people use them. If the node on the other side of this boundary is a VTAM node, make him a border node and make it a full extended boundary. The peripheral boundary restrictions that we have is that if you're going to cross, a session is going to cross multiple network boundaries, the only place where the peripheral boundaries can exist are the very first network crossing and the very last network crossing. Either or both or neither are fine. Any other APPN network boundary crossings that you cross in the middle have to be extended boundaries with border nodes on both sides. Furthermore, if your peripheral network boundary exists, if you have a peripheral network boundary, then you have to, the border node has to be on the inside, if you will. Remember, we said the peripheral boundaries could be the first or last hop. On those subnetwork boundaries that are peripheral boundaries, the border nodes have to be the nodes on the inside of those boundaries. As soon as you cross from a border node to an adjacent non-native network node, that's the last subnetwork boundary you're allowed to cross, because you just crossed from the border node into the network node. That has to be the one on the end of the RCD, if you will, so you're not allowed to cross another boundary. If it happens to span this network and try to get into here, this border node will say, wait a minute, you've already crossed a peripheral boundary, you just crossed a second one, I'm not letting you have it happen, and he'll reject the search back again. So bottom line is, once you cross from border node to network node, you are not allowed to cross any more network boundaries. All right? The other restriction that I've got here is that the peripheral network boundary that you define has to be the only way into that peripheral network. This picture that I've shown you right here is actually invalid because there are two peripheral boundaries that get you into this subnetwork, and that is really not allowed. The problem with two peripheral boundaries into the same network is that I can't tell when my search is looped around because these network nodes think they're sending it to end nodes rather than to border nodes. So I can't tell when searches loop around. You can eventually hit subnet visit count search restrictions. You could get RSCB length restrictions. There are a bunch of different reasons why this might fail, but the bottom line really is that we can't tell, so you could have intermediate failures occur as a result of us not knowing where to send searches or how to prevent searches from repeating their way into another network that's already been searched. So you can have no other extended or peripheral subnetwork boundaries that get you into the same network. You're not allowed to have any subarea connections or SNI connections into that peripheral network. You're not allowed to have any LEN connections into that peripheral network. The only thing that you're allowed to do really is to find parallel links between the same two nodes, so if one link goes down, you could lose a different link. But that really is the only way to get multiple connections into the same peripheral network, if you will.